Hey, I'm Louis. I'm a tech lead with a decade of experience in consulting and startup. For many teams, building a cool demo in a Jupyter notebook is quite doable. However, the pain begins when you need to build a fully fledged product. Why? Because you need to master some software engineering to build new kinds of UI. You need to stream the text of a generated model, and you need to know how to modify your UI on the fly based on the model generation. In this course, we will learn how to do so in detail. We will learn how to set up a generative UI in React. We will learn how to set up a server with FastAPI and LangChain. And we will learn how to cross the network using server-side events.
We will start building an AI product. It will be a very simple use case focusing on the front end. We want to convert some natural language into emojis. So there is a simple text input, to be or not to be. We click on the button and we get an emoji translation. It's made possible thanks to the capabilities of large language model. We are on the OpenAI playground, and we are looking at the completion endpoint. It's a legacy endpoint, which is very useful to understand what are LLM doing. As you can see, here there is the input, which is a sequence, to be or not to. What's the prediction of a large language model? It's the next element in the sequence. The next element is be, to be or not to be. Then this new sequence becomes the new input, to be or not to be, and the next prediction is that. And so on. And we continue it here. And that's how large language model builds their answer. By predicting iteratively the next token. Now let's look at the chat completion endpoint, which is the endpoint we are going to use in this course, and which is the current recommended endpoint. It's a quite straightforward endpoint, a post REST API. Why a post? Because we want some params to be very long. For instance, some conversations can last tens of thousands of characters. And in most browsers, GET requests are limited to 2000 characters. So GET will not work for our use case. Another thing to notice is the API key. You can very easily create a new one. You go to API keys here and create a new API key. Also, one remark, you should not make those API calls from the front end. And we will do so in this course for pedagogic purposes, but that's a way of leaking the API key, so it should not be done in production. If you want to do it properly, look at the module focusing on the backend. The model params is quite straightforward. You pick your model. There is a compromise because big models are smarter, but they are slower and more expensive. So you need to make the trade-off depending on the use case. And last and foremost, the message param. Message is simply the state of the current conversation with different roles: system, user, tool, assistant. We will see later exactly what those correspond. Now, a few remarks. The first is that it's not deterministic. The second is the context window. Not deterministic, let me show you. Here I asked a question, hey, who are you? To the model, and I get an answer, how can I help you today? Let's try exactly the same question. And here I get, I'm an AI digital assistant designed to provide helpful response to user inquiries. So there is a param called temperature that controls how random it is, but even with a temperature set to 0, it won't be deterministic. Second limitation is the context window. There is a maximum size for input, which is a few thousand, dozens of thousands for some models, but you'll need to count token and you'll need to truncate your message in some cases. Here you can see OpenAI Cookbook. We'll look at it in more details in our next module that shows how to count the token for our message. Now, we've seen this API. I just want now to give a few details of how ChatGPT works and how GPT sees the world. We don't need to know that as the model is fully managed, but it's useful because you get a deeper understanding of how to use it, and sometimes it lets you understand some failure case and how to optimize. So the first is the tokenizer. What's a tokenizer? ChatGPT does not see raw text to be or not to be. First, it needs to be tokenized. The tokenizer is a function that takes in input some text, and the output some token which are number. Here you can see the conversion of to be or not to be into a sequence of token. Then the prediction will be another token, and so we need to decode. It matters because sometimes simply making small changes will make big difference on the tokenizer. Here you can see a warning. The warning is caused by the trailing edge space. The trailing edge space changes the encoding. Let me show you the tokenizer playground at OpenAI. I'm adding some my text, and here I get the tokens with colors. And each colors is one token, and here you can see the number for each token. So that's what we are counting when we are talking of a context window size. It's the size of this token list. So now that we briefly see tokens, I want to show you also what are special tokens. Because as you can see in the API, we are sending a list of messages, but that's not what ChatGPT is meant to do. ChatGPT is meant to consume a sequence of tokens. How do we convert this list into a sequence of tokens? With special token, em start, em sep, em end, which are a token we use to indicate to the model that there is a distinct user making this message. Now that we've seen the basic, let's go to the chat playground to play a bit with the OpenAPI endpoint. I encourage you to go to it and to try it. First, the system message. The system message gives personality and context to the assistant. Here I said, you are a jolly pirate. So when the user speaks to the assistant, it answers, "Hi matey, what brings you to a ship today?" Why is that? Because the system gave it a personality. If I say, "You are a king," and then I ask another message, and I get an answer, "Greetings, loyal subject," because I gave it the personality of a king. So that's the power of a system message. Then you have a user message. It's simply a user talking to a model. And the assistant message is content which is predicted by the model. We will learn how to read a servant-sent event stream using native JavaScript functions. As you can see, we have two tasks to do to parse a stream. The first is to decode byte to text, because our text will be encoded to bytes using UTF-8 before being passed to the network. The second task will be to parse the text respecting the server event specification. Let's look at the detail. First, we need to decode byte to text. So here you can see when our text is sent from the backend to the frontend, it's encoded. At the beginning, you have some text. For instance, let's imagine the symbol for euros. It will be encoded into bytes. Here are bytes, 1 byte, 2 bytes, 3 bytes. So now we need to decode it. So that's our first task. The good news is that JavaScript has natively some very powerful functions that will help us a lot. And one remark, it may be that in some environment, on some old browsers, those functions are missing. So you will need to polyfill them with external libraries. But by default, in most modern browsers like Google Chrome, you will find them. So let's look at the Stream API. The Stream API is a JavaScript API. Here you can see the N web docs, which are maintained by Mozilla. I strongly encourage you to visit this documentation. It's excellent if you have any question on the implementation of this API. So here is a diagram. We can see a representation of a stream. A stream is just a sequence of data being sent, and it's processed and rendered as it's being sent. Then, what's a reader? Let's say reader is an object. Will read the content of the stream as it arrives. So it can be processed. How do we get our reader? Our reader is a JavaScript object. And here you can see we have a function fetch data, which return a JavaScript reader with the data encoded as UTF-8. So we make a fetch call, fetch being the native function to make HTTP calls, and we get a standard response. If our endpoint is a server-sent stream endpoint, we'll get a readable stream on the body. And from the readable stream, we can use the method getReader to get a reader. And that's all. We've managed to get a reader. Now, how do we decode? To decode is quite simple. There is a native function called text decoder. in JavaScript, and you pass decoder.decode, and that's all, you get your chunk decoded. So we've decoded our UTF-8. Now, how do we parse the server event? There is a spec that you can find, and we are not going to read every details of the specification, just the core of what we need. Here you can see the spec of how we will. It's a two-step. First, we mostly read line by line. So each line, we consider that each line is separated /n/n. That's the separator. Then we may skip some line, maybe ignore according to the spec, but that's not what interests us. What interests us are lines with a colon, and left of a colon is the field, and right of the colon is the value. And here an example stream, and the field have some valid values. Let's look, it could be event, data, ID, or retry. And if otherwise, it's ignored. In our just looking at the data field, since it's what we need. Let's look at an example stream. Here there is the first line, the field is data, the value is this is the first message, and so on. That's a very simple server-sent event that could be used, for instance, for LLM endpoint. So let's dive into the code. Here you see some JavaScript function. In the signature, we have two properties, a reader. So a reader is a standard JavaScript object, like I showed you, that could be sent as the response of a fetch function. And an event. An event is simply a function that will be called anytime a new event is ready to be processed. And our job will be to call that method anytime an event is sent from the stream. So what do we do? First, we loop until the stream is closed. We read our reader. There is a method read, we just read it. We will break our loop once this reader is closed. Then we will decode. As I told you, we are decoding the chunk to UTF-8. Then we are adding, because we have no guarantees that from on the network, each line will be sent as one chunk. It's perfectly possible for each line to be chunked. So once we have an entire line, and we know it because by according to the spec, lines are separated by /n, we now can parse the line. So we get the line, we remove the line from the buffer. If it's a comment, according to the spec, we just ignore the line. Otherwise, we can get in the field and the value. Here is the field, here is the value. Now, just to simplify our job, we are going to try to parse it as JSON. And then we call the event method. And here we have only implemented the data case because it's what we need for LLM. But we could implement the rest, an event, and so on. So now we've implemented the first part of read the stream. As you can see, it's just much easier because native JavaScript functionality is very powerful. In this lesson, we will build the use completion hook, which is a function encapsulating the logic for our use case. Let's talk about the separation of concern. It's often a good idea to make code modular if possible. Let's think about our application. What are the core tasks that need to be needed? We need to handle the network. And there are many edge cases, there's many things can go wrong. For instance, maybe the network shuts down and you get an error. Maybe there is a timeout problem because the server is overloaded. Maybe you make several requests, but they don't arrive in the same order they were made, and so on. So there is quite a lot of logic to handle for network. Then streaming. And let me notice that streaming and network are indeed different concerns. As whether or not you are streaming, you still need to handle the network. So streaming is just to make sure that the data can be processed as soon as it is right on the front end. And the last is the use case. Here it's our completion use case. It could be a chat use case. It could be an assistant use case. And for every use case, you will still need to handle network and streaming. So let's begin with the network. How are we going to handle the network logic? With a hook. And I will advise you to use a library called React Query. Now it has a new name called TanStack Query. It's very famous and very powerful. And it completely handles the network query for you. So thanks to this library, we built a hook called use chat query. with text and input messages, and an output wants a reader query. So the reader is from the streams API we saw in the previous lesson. Now, as you can see, the hook is very short, as the core logic is handled by use query. What do we need to do? Simply to build a key. The key is used by the cache. As long as the key does not change, we can reuse the cache. Then we need to pass a function making the actual call. And what's very powerful is that we can pass many functions depending on the runtime context. Then a few config, last tail time. We need to know how long the cache should be kept and enabled. Sometimes we want to skip the call if the params are not ready. So that's all for the network logic. Now, let's see the streaming. The streaming, we already dedicated an entire lesson to it. It's the previous lesson. And we created a function readTextStream, which is dedicated to handle the streaming. So I'm skipping. You can go back to see the details. Lastly, completion. So completion will be a hook that takes an input messages and which returns a completion query. So it depends on our two previous blocks. The network block, which is UseChat query, we will do a dependency injection by passing UseChat query in as a property. That will be very useful, for instance, for testing. And it depends on readTextStream, is it here, which will simply import. So now we have our code. It's quite simple. Let's go over it to see any trap. We have our standard state. We need to keep loading state, reading, which at the end will be concatenated to return the different state is loading is data. And here we are making the actual network call. You can see there is the reader. Then the reader is read with REST text stream. Everything is very simple. Here you can see the loading set is handled, the errors are handled, and so on. Fairly straightforward. Now let's look here. It's a bit more tricky. Here we are passing to readTextStream the onEvent function. It's the function which will process the event. So what do we do? First, we check the field is data. And here we are using a library called Zod, which is standard TypeScript library, simply to check that the data has the expected format. And here we are expecting an OpenAI chat completion chunk. But of course, you are free to use any type of formatting you want. And here we are write the core logic of our use case. What's the logic? It's simple. We are simply taking the previous value and we are adding the new chunk. And that's all. Now, there is still one trap. You need to be a bit wary. React batches updates. What does it mean? Let me show you the documentation. Here you can see there is a button plus free. On click, you have free updates. Set number +1. Now think, what do you expect to happen if I click on this button? You may freeze the video if you want to think about it a bit. Now let me press. I get 4. How is it possible? Because there is free update and yet I get 4. Here is simple. React batches update before render. So what happens is that there is an update which is number +1. Number was a value of 3. 3 +1 is 4. And in the end, those updates are lost. So there is an easy way to fix that. Instead of passing the new value, you pass a function. It's a function that takes the previous value as input and then gives the output. So the output is n+1. And now if I click, it works. So that's exactly the case we are facing with streaming. Because we could get a case where the streaming is so fast that the updates end up being batched before rendering. Here, we do not want to simply return prev plus the chunk. We really want to pass a function computing the update. So that's the little trick that you need to be aware of. And now we've built our use completion and we can build our use emoji. You have 10 lines of code. You have a very powerful functionality. Here we have a message. Let's say we have an ID for convenience. We have a system message with telling convert text to emojis. Here we have a user input and here we have a completion query. and that's all. And with that, you could build any type of completion use case. For instance, you could get a spell checker. You could build the title of a to-do list automatically, and so on in a few lines of code. So thanks a lot, we have managed to build our functionality. We will learn how to render the output of our completion. As you can see, it's simply a text string. So it's very simple. You just need to insert the text in the HTML template and it's done. There is only one thing to know, is that GPT uses Markdown syntax to format the output. So you will need to use a library to render Markdown. And here we are using React Markdown, which is a very used library and easy to use. So you simply use React Markdown and you input your text. You may have some problems with line breaks and a plugin may be needed. Here we are using Remark Breaks, which is another NPM plugin, but it's fairly straightforward. Lastly, what may be a quality of life improvement is to add a loading indicator and a reading indicator. The loading indicator is when the first token has yet to be predicted. We add a little pulsating dot, and the reading indicator, just during the streaming, we add a dot. We made a pulsating dot using Tailwind. You can look up the code. Now, let's go to the next lesson, which concern mocking the stream. We will learn how to mock a stream. Why do we want to mock a stream? There are two main use cases. The first is to run the front end without a backend. The second is for testing purposes. Very often, you end up needing to run your front end without a backend. For instance, you are launching a full stack project, but it's not clear when this backend will be created. Maybe there is some uncertainty on how it will be deployed, we will deploy it, what stack will be used. Another very frequent problem is that there is another team owning the backend and some change needs to be done. Maybe there was a breaking change, maybe the server is down, maybe it's hidden behind a notification firewall and so on. And you are forced to wait for the other team to take action. You can still work on your front end as long as your code is well structured in such a way that you can replace the network layer as needed. It's often called the hexagon architecture, onion architecture, clean architecture. Second use case, testing. Because we want to test our code without making API calls every time in our CI/CD pipeline, for instance. And here, mocking will be very useful. How do we do it? As we saw in previous lesson, the Stream API is a native JavaScript API, very powerful, and we are going to use it to create our own stream and to control it. So you can see the function build mock stream. What does it do? It creates a new stream instance. It's a readable stream. And here we need to pay attention that we are returning a reader and a controller. The reader will be used to read the stream, and the controller will be used to control the stream. Controlling means that you can unqueue new information in the stream, that you can close the stream, and so on as needed. So you get full control over the stream you created. Another thing we note is because we want to encode the text into UTF-8, so we use the text encoder built-in function to encode. As usual, you can go to MDN. The doc is amazing. It's a great explanation, and there are some code samples. You can go on this page using readable streams. You have many examples that give you a better understanding of how it works and how to use the API. Let's go over the usage of this stream. Here we are building a new implementation of a fetch chat function. And if you look at the interface, you'll see that it can be passed to a use completion hook. And here we are building the mock stream. We get a reader, we get a controller, and we build an unqueue chunk method. And we use a set timeout because we want to replicate the streaming effect where events come one by one across the time. So here we are building a data chunk. It's a server sent event. It's encoded. We created our own schema of server sent event. It's a LLM chunk, and we encode it across time. And that's all. And if you pass this method to a use completion hook, where you will get the standard functionality with the sample text you need. Here I put a sample text but you can put so emoji anything you want, you get full control. We will reuse this stream for testing.
Thanks for watching. If you want to keep learning, click the link in the description below.
For the last few years, I've been helping organizations leverage large language models to transform their process. I've been working with public institutions like the UNESCO or the government in Singapore, and also with private companies like a car maker or private equity funds. Let me show you the demo app. We will build this app from scratch in the course. It's deployed publicly, you can try it. So we will build a very simple completion use case, converting text into emoji. We will build a chat use case where we talk with the model. We will build a retrieval augmented generation use case where we want to ask some question and get an answer based on a trusted document. And we will build some agentic workflows. Here we can see some tool usage with an external API. Let me show you the code execution. Now we are asking for some code to be written in Python, and we get some code which is executed. Last but not least, a data analyst. We ask the model to analyze the famous Titanic dataset. So the model writes some SQL and then makes a chart. I'm looking forward to all the amazing products you will be able to build from this course. See you soon.